Warning, the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This is yet another video within the pre-calculus series for review of trig, but this specific video is, for at least in our curriculum, not material that's covered in our trig class, so this should be new. Maybe not to you, but at least to students at our college and within our college district. Had a hard time searching for that word. So let's go ahead and talk about the area of a sector. First of all, I want to just showcase what I mean by the area of a sector. So let's pretend as though you have a circle, and the circle has radius r. And what you're going to do is cut out an area with an angle theta. So you get an arc length here of arc length s, and we know from a previous lecture that s is equal to r theta, where theta is in radians. But that's not actually what we're talking about here. What we want to know is, what is the area of this region that gets cut out when we open that angle of theta up? So what is this area that I'm shading right here, or highlighting, I suppose, is probably the better way of saying it. And it turns out that the formula for that is area equals 1/2 r squared theta. Now that formula is really not hard to derive. In fact, it's incredibly easy to derive that formula. So let's go ahead and showcase, and by the way, sorry for the poor quality on this. My network must be experiencing some lag here, but anyway, let's go ahead and derive that formula. So let's see, as far as percentage of the circle, let's talk about what percentage of this full circle that we have. Well, okay, if the full circle is 100% of the circle, and this little mouth part of Pac-Man here is a certain percentage, it's going to be theta out of 2 pi of the circle, right? That's really what it is. It's, if you were to think about it in terms of a portion of the circle, it'd be theta out of 2 pi of that full circle. If theta were, let's pretend, pi, then it would be pi out of 2 pi, or in other words, 1/2 of the circle. If theta was 2 pi, it'd be 2 pi out of 2 pi, or the full one circle. But in this case, we don't know what theta is, so it's just theta out of 2 pi. So the area of that shaded region is going to be, I'll zoom in here, theta out of 2 pi of the full area of a circle. Well, what is the full area of a circle? Well, you should know that. It's pi r squared. And if you notice, the pi's will cancel beautifully, and you will get a theta with an r squared all over 2, or how we often write it in this course is 1/2 r squared theta. There you have it. That's the full proof. Not very much to it, right? So QED, we are completely done with that proof, and we can now start using the area of a sector formula. And I think I fixed the issue. It was my server backing up, so there we go. All right, so let's do an example using the area of a sector. An irrigation system uses a straight sprinkler pipe 200 feet long that pivots around a central point. Let me draw a picture of this really quickly. So this sprinkler system uses, I don't know if you've seen them, but they're usually out in farmlands where they have a straight sprinkler pipe, and it just douses the area with water as it rotates through. So it rotates through an angle when it does that. And the pipe does, that is. But due to an obstacle, the pipe is only allowed to pivot through 295 degrees. So it can rotate all the way to 180, then 270, and a little bit more, but no more than that. So let's just call this angle here 295 degrees. And so the water is getting on basically all of this area, but not the corner area there. So the question is, what is the area watered by this sprinkler system? And we happen to know the formula, just because we just learned it, is area is equal to 1/2 r squared theta. But the critical thing to remember here is that theta must be in radians. And this is going to be a theme throughout pre-calculus and then calculus. Everything has to kind of be in radians, because if it's not, you have some issues. So let's go ahead and plug everything in. So area is going to be 1/2. Let me switch my pen color here. 1/2 that 200-foot pipe squared, and then times the angle, which is 295 degrees. I'll just write it as 295 times 1 degree, and I'll do my conversion. So that's 1/2 of 200 squared is 4 with 4 zeros. And, oh, by the way, that's square feet, right? Because you squared the feet as well. So that's 40,000 square feet. And then 295 times 1 degree, and 1 degree is pi over 180 radians. Now, obviously, I'm going to grab a calculator here, but maybe not so obviously, because sometimes instructors want you, myself included, I'm this way, some instructors want you just to write this as a fraction in exact form. So I'm pretty much game with that. Let's suppose that this was an exam and you were not allowed a calculator, and your instructor just said, write this in exact form. You could write it like this: 40,000 pi over, times 295, all over 2 times 180. You could totally leave it like that. Don't forget that it's square feet. Or if your instructor is really picky, and I'm not super picky about this, but if your instructor is, they might say, just do a little bit of arithmetic. Well, 2 goes into 40,000 20,000 times. At least I get that down, right? And we still have that 295 hanging out back. And then we have 180. But I happen to know that 180 is divisible by 5. But you know what? I'm not going to bother with the rest of this, because again, I would be perfectly fine on an exam for students leaving their work like that if I don't allow a calculator. Mainly because these are stupid numbers, very large numbers. So let me go ahead and just do the rest of the computation using a calculator. And we get 102,974 square feet. That's roughly, it's rounded to the nearest square foot. So that is a good initial example of how to use the area of a sector formula. There are more advanced uses for this formula though, and you'll see that in a pre-calculus course in the homework, but I figure it might be nice to go ahead and give you an example of what I mean by that right now. So let's go ahead and try something. So let's suppose that your neighbor has a goat on a leash that is allowed to graze, and the leash is actually pinned right here where that red dot is, and the leash is 40 feet long. What's the total area that the goat can graze? Well, let's go ahead and see what this area looks like. If that's about 25 radius right there, let's go ahead and blow this up a little bit until it gets to roughly what we consider to be around a 40-foot radius. I think maybe around there. I know that the 80 is not to scale. That's totally fine. But we have this grazing area. This is 40 feet over there, and it can go all the way out to there, 40 feet. But then once it gets to that moment right there, it doesn't have 40 feet of leash there anymore. Let me just take that away. You can see that it could graze all of this. Whoops, I didn't mean to do that. Let me hop back here a couple steps and let me just make this disappear. All right, you can see that it could graze all this. I'll use this color here, all this land right here. This is all within 40 feet. Okay, so let me erase that 80, and I will just say that this distance right here is a 40-foot distance. So it's allowed to eat all this because the leash is 40 feet long. However, once it reaches this corner, once it gets there, it no longer has a 40-foot leash at this moment. It only has 40 minus 25 left to eat in this area right here. And so 40 minus 25 is 15. So it has a 15-foot leash on that little sector right there. And just to showcase what I'm doing here, I'm just basically saying, okay, so once that leash kind of goes all the way up here, there's the 40-foot section of it. But if the goat starts walking in this region, well, 25 feet of the leash is taken, so it can only go an extra 15 feet over here. But then it can always graze this entire region over here, so I'll just do that. So there we go. We want to know, what is that total area it can graze? Well, remember, the area of a sector formula is 1/2 r squared theta. And now we can actually just work in radians. So this angle right here is a right angle, which is pi over 2 radians. And this angle actually is a right angle, a pi over 2 radians. There are two areas, area 1 and area 2. So area 1 is going to be 1/2 its radius squared, so 40 feet squared, times the angle in radians, pi over 2. And area 2 is going to be 1/2 its radius squared, 15 feet squared, times its radial angle, or radian angle. And that's what we get there. So 40 squared is 1600. And 1600 divided by 4 is 400 pi square feet. And let's see, this is 225, and unfortunately that is not divisible by 4, so it's 225 over 4 pi, again, square feet. And so the total, you would grab a calculator to sum those up. The total area is just area 1 plus area 2. So I'm going to grab a calculator really quickly, and I get approximately 1,433 square feet. That's a really fun problem, very good problem, great for a pre-calculus exam. That is a wonderful problem right there. All right, there's nothing else I can really do with arc length, but man, oh man, once we get into velocities, there's a lot I could do there. So let's go ahead and move on, and I'll see you in the next video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much, that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.